It is the paired test. It is the paired, the non-parametrically. We apply the paired test. So it's actually we have to compare. In this case, we have the paired sample. So we have, even though we have two groups, this one is a wife and that is a husband, then we can make the pair. This is the couple and that is another couple and that is another couple. So it's actually we have two populations. It is the population number 1 and that is a population number 2, but we can make the pair, this one and this one, this one and that one. So we described it is the paired the data, or the paired sample, or sometimes it's a dependent data, the dependent sample. So parametrically we apply the t-test. So even though in step number 1, yeah, absolutely, it is a parametrical, it's a paired t-test. So we assumed the normal distribution or the large sample. Then actually we had the two groups. So we stated the hypothesis is like as the pooled t-test, but it's actually we got the difference. So based on the difference, yeah, simply we just apply the one sample t-test. So that was the paired t-test. It's the same idea. Even though the non-parametrical, we are going to take the difference and simply we applied the signed rank test. Can you remember the Wilcoxon's the signed rank test? You know, it's actually it was same as the one sample we compared to the one sample t-test. So it's almost the same idea. After we take the difference, parametrically we applied the one sample t-test. It's like as that. The non-parametrically, yeah, we are going to assign the rank test. So you know, the actually today it is a review. It is a review of the signed rank test again. Yeah. So we take the difference and we take the absolute value of the difference and assign the rank and the signed rank, and we are going to take the sum of the positive ranks, and we are going to take the critical value from the W table and make the decision and conclusion. So let me look at the example, this one. So it's actually, this one is the age. This one is the age of the marriage. So this one is the husband's age when he got married with his wife, and wife is 53, and the age difference was the 6. And the second couple is husband was 21 and wife was 22. The difference age was as -1. So now we assign the rank. Always we rank number 1 is the smallest one. So the smallest one means, the before the rank, we take the absolute value of the differences. So it's a 6, 1, 3, 4, 6, 2, 1, 4, 13, and 8. And now let me assign the rank. The first one, the smallest one, that is a rank number 1, and they must be the rank 1 and rank 2 tie. Then we take the average is 1.5 and 1.5, and the next one is a 2, is only 1, so it's 1, 2, and that will be 3, and next one is the 3, right, will be 4, and the age difference 4. The age difference 4 will be rank 5 and 6. So the average will be 5.5 and 5.5. And the next one will be the rank 7. rank 7 for 6. So it's a 7 and 8. It's a 7.5 and 7.5. And the next one will be rank 9 and rank 10, because we had 10 couples. And now we get the signed rank. So that will be it's a 7.5 and negative 1.5, negative 4, 5.5, 7.5, and negative 3, and positive 1.5, 5.5, 10, and 9. And now, I'm sorry. Now we apply the 5 steps. So it's a step number 1. Actually, we have 2 groups, even though they are paired, they are dependent, but the null hypothesis is mu1 is equal to mu2, and we have to choose the inequalities for the alternative hypotheses. But what was the claim? Okay, here it is. Yeah, we want to test the differ from, right? So it must be, it's a not equal to, it's a two-tailed. And the test statistic, was the W. The W was the rank sum of positive. So you can take the sum of, it's a positive ranks. It will be 46.5. And now step 3, we need a critical value. Actually, the distribution will be symmetrical. Yep. So I can take the distribution for W, the test statistic W, from 0, and it's up to the maximum sum of the rank. That will be 10 times 11 over 2. That is a 55. So I can think about the symmetrical distribution from 0 to 55. And now let me take the critical value. So I have to go to the table W. It's actually the table 5, the W. And now the alpha was 0.05 for two-tailed. So I have to, okay, let me go back. I have to split the alpha 5% is a half here and half there. That means here is a 0.025 and there is a 0.025 too. It's a split, it's a two-tailed because it was a two-tailed. So I have to take the 0.025 and the sample size is equal to 10. So the critical value will be 47. So let me go up. So now I can say, so here is 47, and it must be 55 as minus 47. But the test statistic was 46.5, just before the 47. The W, the test statistic was 46.5. Then what will be the decision? Fail to reject the null hypothesis. It's not reject the null hypothesis, not reject. So that means that null statement is true. It's a no different age. Okay, so today, just we review, what was the signed rank test. But now we took the differences, right? Because basically we had two groups, but after we take the differences, simply it's just one sample. So parametrically, we assign the one sample t-test, but today, non-parametrically, we apply the Wilcoxon signed test.